Hi friends, today I am giving a lecture on Flynn's classification of computers in computer organization and advanced computer architecture. Okay, so this is one of the most important concept in computer organization and architecture. Okay, so for the organization of a computer system based on the number of instructions and data that are manipulated simultaneously. For that purpose, Flynn proposed a classification. Okay, the Flynn classifies the computers into four categories based on the number of instructions and data items that are manipulated simultaneously. First one is SISD, single instruction stream and single data stream. Second one is single instruction stream and multiple data streams, SIMD. Third one is multiple instruction stream and multiple data stream, MIMD. Fourth one, multiple instruction stream, single data stream, MISD. Okay, so before going to the SISD, SIMD, MISD, MIMD, okay, what is instruction stream and what is data stream? So generally, the programs are stored in the main memory. A program is a collection of instructions that are stored in the memory. To process that instructions, okay, that instructions can be read from the memory. Okay, so the sequence of instructions read from the memory is called as instruction stream. So instruction stream is nothing but the sequence of instructions read from the main memory is called as instruction stream. Once the instructions are read from the memory by the CPU, then what are the operations that can be performed by the CPU? That is called as data stream. So data stream is nothing but the operations performed on the data in the processor is called as data stream. So based on the instruction stream and the data stream, Flynn classifies the computer into four categories: SISD, SIMD, MISD, MIMD. Okay, so this diagram shows the four major categories of Flynn's classification. Here single, here multiple, here single, here multiple. So single instruction stream, single data stream, that is SISD. Single instruction stream, multiple data stream, that is SIMD. Multiple instruction stream, single data stream, that is MISD. Multiple instruction stream, multiple data stream, that is called as MIMD. Okay, single instruction stream, single data stream, that is SISD. Single instruction stream, multiple data stream, that is SIMD. Multiple instruction stream, single data stream, that is MISD. So multiple instruction stream, multiple data stream, that is called as MISD. Okay, so once again I am telling, instruction stream is nothing but the sequence of instructions read from the main memory constitutes an instruction stream. The operations can be performed on the data in the processor constitutes an data stream. Okay, now we go for individual. What is SISD? What is SIMD? What is MISD? What is MIMD? Okay. Now we go for SISD computer. That means single instruction stream and a single data stream. Okay. So this diagram shows the SISD computer. It represents the organization of a single computer that consists of a single control unit, single processing unit, and main memory. Here in this SISD computer, instructions are executed sequentially, one after the other. Okay. So the SISD computer may not have parallel processing capability. In case parallel processing capability can be achieved by means of multiple functional units, that means multiple ALUs and also pipelined processing. Okay, here SISD computer may not have parallel processing capability. Suppose we require parallel processing capability through SISD computer, we may require multiple functional units, that means multiple ALUs or pipelined processing. So by using these two concepts, we have to achieve the parallel processing capability in SISD computer. So generally in SISD computer, instructions are executed sequentially, one after the other. Okay. Now here in the main memory, the instructions are stored in the main memory. These instructions are executed sequentially, one after the other. Okay. For that purpose, the control unit reads the instructions from the main memory for decoding purpose. Okay. So at that time, the sequence of instructions sent to the control unit as a instruction stream. Now the control unit sends that instruction to the processing unit for process the instruction. Now the processing unit is nothing but ALU. The processing unit executes the instruction by taking the data from the main memory. For that purpose, we have to use data stream. Okay. So now the processing unit executes the instruction by taking the data from the main memory and execute that instruction. Whatever the output that can be generated from the processor unit, so that can be sent to the main memory. Okay. Here the data can be flowed between the processing unit and main memory, and the main memory and processing unit. So the data can be communication between bidirectionally between these two units, processing unit and main memory. Okay. So in this way, we have to process the instructions in SISD computer. Okay, once again I am telling, here the instructions are stored in the memory. Okay, so that instructions are executed sequentially by the processing unit. So first the control unit reads the instructions from the main memory as a instruction stream for decoding purpose. Once the decode phase is completed by the control unit, then sends the instructions to the processing unit. Okay. Now all the instructions are stored in the processing unit, that is ALU. Now the processing unit can execute the instructions by taking the data from the main memory as a data stream. Now here the instructions and the data is available in the processing unit. Now the processing unit executes the instructions. So then it produces the output data. This output data again send it to the main memory as a data stream. Now the output is stored in the main memory. Okay, this is the how to execute the instructions that are stored in the memory by the processing unit in SISD computer. Okay, so SISD computer, the examples for SISD computers are older generation computers, mini computers, and workstations. So these are the examples for SISD computers. Okay, in SISD computer, so some computers have one functional unit and some computers have multiple functional units. Okay, here in this computer, instructions are executed sequentially one after the other. So in this computer, instructions are executed parallelly by using multiple functional units. Okay, so SISD computers have one functional unit. So for that one, the examples for that one are IBM 701, IBM 1620. SISD computers have multiple functionality. So that computers are IBM 36091, CDC 6600. So these are SISD computers have multiple functional units. So for that computers, the examples are IBM 36091, CDC 6600. Okay, SISD computers have single functional unit. For that one, the examples are IBM 701, IBM 1620. Okay, now we go for SIMD computer. In SIMD organization, single instruction stream, multiple data stream. In SIMD organization, it consists of multiple processing units such as PU1 processing unit 1, PU2 processing unit 2, PUN processing unit N. So SIMD organization consists of multiple processing units and one shared memory unit. In this shared memory unit, so the shared memory can be divided into multiple memory modules such as MM1, memory module 1, MM2, memory module 2, MMN, memory module N. Okay, so the shared memory is divided into multiple memory modules varying from memory module 1 to memory module N. Okay, so here it consists of several processing units such as PU1 to PUN. All the processing units are controlled by a single control unit. This is PU, this is single control unit. Okay, so we can say that SIMD computer consists of multiple processing units, one single control unit, and one shared memory unit. Now this shared memory unit can be divided into several number of memory modules for communicating different processing units. Okay, all these processing units are controlled by a single control unit. Okay, this is the control unit. This single control unit can monitor all the n number of processing units. Okay, now the control unit receives the instructions that are stored in shared memory in the form of instruction string. Okay, so all the instructions are stored in the shared memory. The control unit can read the instruction from the shared memory in the form of instruction string for decoding purpose. Next, the control unit sends the same instruction to the n number of processing units, where n number of processing units can execute the same instruction on the different data streams. Okay, so this processing unit can execute the same instruction but execute on different data items that can be taken from memory module 1. Okay, this processing unit can execute the same instruction that are sent by the control unit and on different data streams that are taken from memory module 2. Next, this processing unit can execute the same instruction that can be sent from the control unit but executes on different data streams that can be obtained from memory module n. Okay, this processing unit can execute the instruction stream on data that can be obtained from memory module 1. This processing unit can execute the same instruction that are sent by the control unit on different data streams that can be obtained from memory module 2. Okay, this processing unit can execute the same instruction that can be sent by the control unit but execute on data that can be obtained from memory module n. Okay, we can simply say that this processing unit can execute the data taken from the memory module 1. This processing unit can execute the instruction that can be taken the data from the memory module 2. This processing unit can execute the instruction on the data that can be obtained from memory module n. Okay, we can simply say that all the processing units can execute the same instruction that can be sent from the control unit but execute on different data streams. Okay, so this processing unit can execute the data that can be taken from memory module 1. This processing unit can execute the data that can be taken from this memory module 2. This processing unit can execute the instruction that can be taken from the data from memory module n. Okay, so because of that reason, the shared memory can be divided into multiple number of memory modules. So each and every module can send the data to the corresponding processing unit. Then the processing unit can execute that data with the instructions that are sent from the control unit. Okay, so because of that reason, so SIMD computer consists of a single control unit, multiple processing unit, and one shared memory unit. In that shared memory unit, the total shared memory can be divided into several number of memory modules. So each and every memory module can send the data to the corresponding processing unit. Okay, so this is a single instruction string and multiple data streams. Now, array processors and vector processors comes under SIMD computer group. Okay, now the examples for SIMD computers are foreign computers, ILIAS-4 computers. So these two computers comes under single instruction stream, multiple data stream computers. Now here the abbreviation CU means control unit, PU means processing unit, MM is nothing but memory module. Okay, now we go for MISD computer. Now the third type of computer is MISD computer, multiple instruction stream and a single data stream. So this is the MISD organization or MISD architecture. This MISD architecture mainly consists of n number of control units and n number of processing units and only one shared memory unit. So this shared memory unit can be divided into several number of memory modules, that are memory module 1 to memory module n. Okay. Now, so each and every control unit can read the instructions from the corresponding memory module as a instruction stream, so that are sent to the corresponding processing unit. So this processing unit can execute the instructions that are sent from the control unit 1 with the data taken from the shared memory unit. Now, processing unit 1 execute that instruction. Whatever the output that we are getting, that output can be sent to the processing unit 2. This processing unit can read the instructions sent from the control unit 2 and execute that instruction with the data taken from the processing unit 1. Okay. Whatever the output that can be obtained from processing unit 2, that are sent to the next processing unit. Suppose this is the next processing unit PUN. So PUN can execute the instruction that are sent through the control unit N with the data that is obtained from processing unit, previous processing unit. Okay. So then execute that instruction, that whatever the output we are getting, that output can be sent to the processing memory module as a data stream. Okay. So this is the process can be done in MISD computer. Okay. This MIMD computer has only the theoretical concept, but there is no practical implementation. Okay. Up to now, there is no computer has the MISD architecture. Okay. So once again, I am telling how the execution can be done in MISD computer. In MISD computer, it consists of n number of control units, that are control unit 1 to control unit n, and n number of processing units are there, that are processing unit 1 to processing unit n, and one shared memory unit. This shared memory unit is divided into n number of memory modules, MM1, MM2, MMN. Okay. Now, there are n number of control units are there. Each and every control unit can read the instructions from the corresponding memory module as a instruction stream. Okay. Now, control unit 1 sent the corresponding instruction stream to the processing unit 1. The control unit 2 can send the corresponding instruction stream to the processing unit 2. Control unit N can send the corresponding instruction stream to the processing unit N. Okay. Now, this process unit can take the instructions from the corresponding control unit with the data and execute that instruction with the data taken from the shared memory as a data stream. Okay. Now, what are the inputs for processing unit 1? The data taken from the shared memory unit as a data stream is the one input, and the control unit can send the instruction stream 1 that are read from the memory module 1 as a instruction stream 1. This is the second input. So now the processing unit can take these two inputs and execute that instruction with the data taken from the shared memory unit. Now, whatever the output we are getting from processing unit 1, that output can send it to the processing unit 2 as a input. Now, the processing unit 2 can take the instructions from the control unit 2 that are taken from the corresponding memory module. Now, the processing unit 2 can execute the instructions IS2 with the data taken from the processing unit 1. Now, whatever the output we are getting from the processing unit 2 that are sent to the next processing unit. Suppose next processing unit is PUN. PUN can take the data from the processing unit 2 as one input, and another input is the instruction stream N read by the control unit N from the corresponding memory module. Now, whatever the output we are getting from the processing unit N, so that output can be sent to the shared memory unit as a data stream. Okay, so now in this way the execution can be done in MISD computer. This computer has only a theoretical concept computer, but there is no practical implementation is there. Up to now, so there is no computer has the MISD computer architecture. Okay, so this example for MISD computer or Carnegie Mellon C.MPP computer. This computer has only MISD theoretical concept, but there is no implementation of MISD architecture. Okay, so the abbreviations are CU control unit, PU processing unit, MM memory module, IS instruction stream, DS data stream. Now we go for MIMD computer. Next computer is MIMD computer. In MIMD computer overall organization, it consists of n number of control units, n number of processing units, and n number of memory modules contained in a shared memory unit. Okay, so here one shared memory unit is there in MIMD organization. This shared memory can be divided into n number of memory modules. Okay, next here the control unit 1 can read the instruction stream 1 from memory module 1 in shared memory unit. So whatever the instructions that are sent to the processing unit 1 as a instruction stream, this processing unit 1 can execute the instructions that are read from the memory module 1 via control unit 1 with the data taken from the memory module 1 as a data stream. Now it can execute the instruction with these two inputs by the processing unit 1. Now whatever the output we are getting at processing unit 1, that are again stored in memory module 1. Okay, next the control unit 2 can read the instructions as a instruction stream from the memory module 2 and send it to the processing unit 2. Now the processing unit can take the instructions from the control unit 2 that are read from the memory module 2 with the data taken from the memory module 2. Now processing unit 2 can execute that instructions and send it to the memory module 2. Okay, now next processing unit, suppose processing unit N. This processing unit N can read the instructions from the memory module N by the control unit N with the data taken from memory module N as a data stream DSN. It executes that instruction and send it to the output to the memory module N. Okay, so here there are n number of control units are there. These n number of control units can control the n number of processing units. So each and every control unit can control the corresponding processing unit. Okay, now each and every control unit can read the corresponding instruction stream from the corresponding memory module, and whatever the instruction streams that are read from the corresponding memory module that are sent to the corresponding processing unit for execution. Here each and every processing unit can take the corresponding instruction stream from the memory module by the corresponding control unit and execute that instruction with the data read from the corresponding memory module. Now, whatever the output we are getting from the processing unit, that output again stored in the shared memory unit. Okay, so this process can be done in MIMD computer. So in MIMD computer, so all the instructions are executed parallelly by the n number of processing units with the data taken from the n number of memory modules with the support of n number of control units. So MIMD computers are used for parallel processing. Okay, so parallel processing can be achieved through the only MIMD computer because here instructions are executed parallelly because of n number of processing units and n number of memory modules and n number of control units. Okay, for parallel processing applications we are using MIMD computers. Okay, here several number of instruction streams are there, several number of data streams are there. Okay, each and every instruction stream can be executed by the corresponding processing unit with the support of corresponding control unit, the data that can be taken from the corresponding memory module. Okay, so the example for MIMD computers are Cray 90, Cray T3E, IBM SP2, Unibank 1100. Okay, these computers are called as MIMD computers, multiple instruction stream and multiple data stream. In these computers, the instructions are executed parallelly. Okay, so the abbreviations are CU, control unit, PU, processing unit, MM, memory module, IS, instruction stream, DS, data stream. Okay, so this is the Flynn's classification of 4 computers: SISD, SIMD, MISD, MIMD. Okay, so thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Dibbela Srinivasarao. Dibbela Srinivasarao. So I am telling each and every computer in a briefly manner. So thank you patiently for watching.